Alright, guys, today we are going to talk about molarity. First thing I want to do though is thank Nicole, Natalie, RJ, Minty. You guys are amazing. Without you guys, none of this would be possible. I am truly blessed to have friends like you guys. Alright. So, molarity, which is moles per liter. It's like super common. It's something you'll use pretty often in chem, especially with solutions. So what do you call one tooth inside of a liter of water? A 1 molar solution. Alright. I guess it's not that funny, but still, I like it. Okay, so we'll jump right into an example. We're going to calculate the molarity of a solution containing 25.05 grams of silver nitrate. Now you remember that nitrate is NO3 minus. And you will also remember that silver is Ag plus. So when you put those together, that'll give you AgNO3. It has a molar mass of 169.88 grams per mole, and it's dissolved in 100 mils of water. So the first thing you'll do is turn these grams into moles. So 25.02 grams of silver nitrate divided by the number of grams in a mole, which is a molar mass, will give you the number of moles of silver nitrate that you have, which is 0.1474, and then I put the little 5 down here. That's your first insignificant figure. You'll see me using this a lot. It's just something that I'm learning to do for my chem class. So now it's important to not just stop here, because that's only the number of moles that you have. It's dissolved in 100 mils of water. So you take your 100 mils and convert it to liters, because molarity is moles over liters, as you can see. So that would give you 0.1000 liters. So we'll take, to figure out the molarity, we'll put the moles over liters, which is the number that we calculated right here, divided by our liters, and our final answer will be this number right here, 1.475 to the correct number of sig figs. Everything in the example had 4 sig figs, so that's the number you're going to go off of. Next example. And you guys, if you see any math that's not right here, please let me know. I'll fix it. Anyways, so if you have a 6.00 molar solution of hydrochloric acid, HCl, how many grams of hydrochloric acid are in 257 mils of that solution? So, by definition, we know that molarity equals moles per liter. Since we have a 6 molar solution for every liter of solution that we have 6.00 molars of hydrochloric acid, or just HCl in this case, because that's what we're worried about. I calculated HCl's molar mass for you. It's 36.46 grams per mole. And then you also want to take your milliliters, since molarity is moles per liter, and convert them to liters. So 0.257 liters, and this is where you start setting up your equation. This should be a really quick thing for you guys to do. You're just moving the decimal 3 places to the left. That's all I did there. So 0.257 liters times our 6 moles of HCl over 1 liter times our molar mass. Our liters will cancel. Our moles of HCl will cancel. And we'll just be left with grams of HCl, which is what we wanted. 56.22 when I did my math, grams of HCl. And then since this number right here is lower than 5, this will be our final answer. We won't have to round up, just leave it how it is. 56.2 grams of HCl for every, or are within 257 mils. And that would be your answer there. And the last one. So this is the equation for the problem right here. What actually ends up happening is you boil this down and you'll get, if you keep boiling down, you'll get basically a white powder. He hasn't worked with it in lab, but we're assuming that you boil it down to where you get a solid, and some of the gas, the water vapor, will interact with this, because you guys have done this where you had the anhydrous and you added a couple of drops of water and it turned blue. This right here is essentially just not going all the way to the end. So how many milliliters of a 12.00 molar CuSO4 solution, or copper 2 sulfate if you prefer to hear the name set out, would be needed, or would need to boil down in order to produce 25.05 grams of CuSO4 pentahydrate? The molecular mass I gave you guys, which is 249.68 grams per mole. To find that, you can just take CuSO4, the molar mass of that, and then add in 5 times the molar mass of water, which you guys should probably memorize, 18.02 or 18.015 grams per mole. But that's how I got that. So we'll start first with the 25.05 grams that we're given of CuSO4 pentahydrate, times the molar mass, so our grams are going to cancel. And then we're moles of CuSO4 pentahydrate, and we'll multiply that based on our equation. It's all 1-to-1 ratio, so we should be good there. And then now we're moles of CuSO4 by itself. This would be the aqueous, if you guys are wondering where this one came from. It came from right here. So now we're in the aqueous version of CuSO4, which we know is 12 moles for every liter. So that will cancel with that, and now we're in liters, but the answer is requested in milliliters. So we have to do that quick little conversion. When I did mine, check it, see if I'm wrong, but I got 8.3608 milliliters, and so everything's in 4 sig figs up there, so you'd have to round up at the end, and you get 8.361 mils. That's assuming 100% yield, which shouldn't be a problem in this case. Alright, well, I hope this helps. Hope this doesn't just confuse you guys. Yeah.